What is global warming? How did it start? How will it continue? What will happen to humanity? Will one day we be gone due to our own ignorance? Global warming is the continuing rise in the average temperature of Earth's climate system.
Through the sudden use of factories, gas-consuming cars, and other emissions from fossil fuels, the Earth's temperature has rapidly increased since the beginning of the Industrial Age.
Global warming is a natural event, but is being majorly contributed to by humans. Today, the quality of the atmosphere has been irreversibly depleted over time, and if nothing is done about it, the Earth will ultimately swelter. Americans are noticing changes all around them already. Summers are longer and hotter, and extended periods of unusual heat last longer than any living American has ever experienced. Winters are generally shorter and warmer. Rain comes in heavier downpours. Tropical storms are much more intense, more destructive, and more frequent. Residents of some coastal cities see their streets flood more regularly during storms and high tides. Inland cities near large rivers also experience more flooding, especially in the Midwest and Northeast. So how does this happen? It is through something called the enhanced greenhouse effect, which is the key ingredient of global warming. Greenhouse gases include water vapor, carbon dioxide, methane, nitrous oxide, and ozone. Greenhouse gases help regulate the temperature of the Earth. The rays of the sun warm the Earth, and the Earth reflects the radiated heat outwards. Greenhouse gases prevent this heat from escaping from the surface of the Earth. Without these gases, the temperature of the Earth would be unbearably colder.
It is the sun that provides our planet with warmth and light, but the amount of energy that the Earth receives from the sun varies. Throughout the Earth's existence, the Earth has gradually changed its orbit around the sun, and with each orbit, the patterns of the energy that the Earth receives are different from each other. These changes have contributed to dramatic shifts in Earth's climate.
The sun's radiation comes in the form of light waves, heating up the Earth. Some of the radiation that is absorbed and warms the Earth is re-radiated back into space in the form of infrared waves. But some of the infrared radiation is trapped by the atmosphere and held inside it. So the problem is that the atmosphere is continuing to consist of more and more carbon dioxide and greenhouse gases due to humankind, and therefore making the radiation from the sun become trapped on Earth, in which heats up the planet.
Since the beginning of the Industrial Revolution, nitrous oxide, which is used in fertilizer, has increased 18%, carbon dioxide from fossil fuel combustion 39%, and methane 148%.
By adding more greenhouse gases, we have altered the natural cycle of the atmosphere, making it harder for radiation to escape to outer space.
Gases in the atmosphere absorb both shortwave solar radiation and longwave infrared radiation, in which this radiant energy warms the atmosphere.
When too much carbon dioxide is put up into the atmosphere, that disrupts the balance, like supersaturating an already existing solution. For example, carbon dioxide already makes up 0.03% of the atmosphere, in which is steadily increasing. If you put sugar into water, there is a limit to which the sugar and water will no longer mix. The same happens here. If you put too much carbon dioxide up, it absorbs infrared radiation depending on its vibration of its bonds. will overall increase the amount of energy and will ultimately increase the overall temperature. Part of this is due to the kinetic molecular theory, meaning more energy causes further vibration, which causes the gases to start bouncing off of each other more quickly. Basically, the overall understanding is that there is a rise in 0.5 degrees to 1 degree centigrade.
The quantity and size of aerosols and molecules in the atmosphere affect the way that they scatter radiation. This difference is easy to observe in the visible part of the spectrum.
Our sky appears blue because the white sunlight coming towards the Earth is scattered by the nitrogen and oxygen molecules in the atmosphere. This process is called the Rayleigh scattering effect. The molecules of these gases interfere with incoming sunlight. The short wavelength blue light is more strongly affected and is scattered in all directions, while the longer wavelength green and red light is able to pass straight through. As you look at the sky, you are seeing the scattered light, therefore the sky looks blue. So if the atmosphere scatters more blue light than red light, then you may wonder why sunsets look red. First, when you look at the sunset, you're looking towards the sun, not away from it. So while all of the blue light has been scattered away, you're looking at the redder light that passes straight through the atmosphere to your eyes. Secondly, the sun is lower in the sky, so the light is forced to travel through much more of the atmosphere. In the process, it also passes through much more water vapor and dust. Water vapor and dust both absorb the short wavelength blue light while allowing the longer wavelength red light to pass straight through to your eyes. Different molecules absorb different wavelengths of light, making a unique pattern in the spectrum, like a fingerprint that we can use to identify the molecules. As mentioned before, one of the largest and most detrimental factors of global warming is the increased melting of permanent ice sheets and glaciers all over the globe. From 1978 to 2004, perennial sea ice cover in the Arctic declined by 7.8% each decade. If these trends continue, late summer sea ice could disappear from the Arctic as early as 2030.
Paleoclimate scientists can learn a lot about the Earth's past climate by looking at the air in the ice, all by analyzing what geochemical proxies that are contained in the air bubbles of the ice.
To analyze this ice, scientists set the ice cores onto a continuous melter, which is just like a hot plate, and it melts the ice core layer after layer. As the water is produced and the included air bubbles are released, it is brought through various instruments, such as a mass spectrometer, for analysis of the chemical composition of the water and the air included. These scientists are specifically looking for properties of the water or air that can reveal what the environment was like when the snow fell on the ice sheet they are probing. This record makes the conclusion that the last 100 years of man-made atmospheric alterations have had a profound effect on the average temperature of the Earth's atmosphere evident. In the ice cores, there are little bubbles, and those individual bubbles contain a real sample of the atmosphere through time. Scientists can then release that air and measure the greenhouse gases. It is almost like taking the DNA of the atmosphere. This record of past climate generated by ice core analysis is essential to the global warming discussion. It creates a benchmark for the pattern of natural variability in the climate record and thereby proves the existence of the man-made enhanced greenhouse effect.
As paleoclimate scientists are struggling to record as much as they can from the ancient ice, they are quickly disappearing. Nearly all ice caps and glaciers in the world have experienced a net loss of volume every year for decades. Satellite and photographic records show this in great detail. One of the places where this is most evident is in the Arctic Ocean, where the Arctic sea ice extent is declining dramatically every summer. Snow nearly acts as a mirror, reflecting the solar radiation back into space. But when the ice is gone and the solar radiation hits liquid water instead, then most of the energy is absorbed by the ocean. and the ocean heats up. This in turn then prevents sea ice from forming and thereby reinforces the warming trend. Every winter the ice grows, and then every summer the ice withdraws. But in recent years, summer melting has brought the ice much further back than scientists have ever seen before. In September of 2012, the Arctic sea ice shrank to its lowest extent ever measured.
Loss of Arctic sea ice is profoundly important for the globe for a number of reasons. First of all, it has a great effect on global weather. We have an ocean that used to be covered with a solid surface that is now depleting. This affects the position of the jet stream, which now extends further north and further south, causing blocking patterns to form which increase periods of extreme heat and extreme cold. It also affects storm tracks like Superstorm Sandy. The Arctic has massive stores of methane in the permafrost and on the Arctic seabed. As we lose the sea ice, we have more heat going into the ocean. That heat will be transported, causing more permafrost thawing and destabilization of the seabed. These processes will increase the overall release of this methane, which will ultimately contribute to the enhancement of the greenhouse effect and cause a spike in temperature. The effects of the polar ice caps melting will also have a significant effect on the chemistry of the ocean, more specifically the composition of the water and the effects it has on living animals. In the past 20 years, overall land and ocean temperature averages have risen by 1.5 degrees Fahrenheit.
Animals most at risk are those who live in the Arctic, especially polar bears. Since a lot of the ice that they live on has melted, they face horrid challenges, sometimes having to swim for hundreds of miles in hopeless attempts to find solid ice. Many are unsuccessful and drown from exhaustion. It is probably a process that will happen too quickly for the polar bears to be able to adjust. Ergo, we are causing their extinction.
We chose to research global warming because we thought it was interesting to learn about the effects that we as humans have on the planet, and we can perhaps learn to control our increasing need for energy and possibly shift our use of fossil fuels to more sustainable sources of energy in order to negate global warming. It is, however, becoming ever clearer that global warming is changing the planet at an ever-increasing pace, and if we ignore the causes, it will be a very different planet that our descendants will inherit.